Hey, folks. Woo, yeah, right? So how was the first day of PyCon? God, I can barely hear you. I feel like there's no one here. Should I just go home and start drinking already? So how was the first day of PyCon? Thank you. All right, we are just going to go ahead and get started. The first talk today is Ping, and the title of his talk is Star Destroyer.
Hi, my friends. I'm here to talk about a dirty, dirty secret that some of us share. Perhaps many of us in the room. Anyone ever written from something import star? Yes, we've all done it. We've all done it. It's so handy, right? When you're just writing a little script, it's quick and easy. So much trouble to name all of the individual things you want to import. Just write import star. It's faster. It's easier. It gets you on your way. No worries. But then your project grows. Maybe it's got more than one file. Maybe you're importing star from your own modules. It could be really tempting if you have a lot of model classes to import all your models with import star. So then maybe you've got a couple files with import star in them, and you're starting to think, well, maybe I should clean this up sometime. I'll get to that later. Well, things can get out of hand pretty quick. 2 uses of import star in one module. Anyone ever come across code like that? Import star from one module pointing at another module that has import star in it. Now you've got a giant mess. Oh man, how'd this happen? It all started out so innocently. Beware the dark side of import star. It's quicker, easier, more seductive. But once you start down the dark path, forever will it dominate your destiny. Consume you it will. Well, it'd be really nice if we were able to just not use this at all to begin with, but sometimes you're stuck with a code base that has some import stars in it, and you just have to deal with it. Sometimes the code is written by other people like you last week. It turns out that solving this problem is actually non-trivial. So suppose, for instance, you've got a module named broccoli, and you're importing star from asparagus. So a first thought might be, OK, let's look at all of the things that are defined in asparagus and look for those names in broccoli and see what's mentioned there. Well, only chop is mentioned there, so you might think, OK, well, we could just replace the import star with chop, and we're good. But it's a little more complicated than that because those symbols can be referred to by other files. So if you've got another module named carrot, it can refer to broccoli.blend, and now the proper functioning of that module depends upon the import of blend that's in broccoli. So a second thought I had was, OK, well, maybe we can run Pylint on this, because Pylint is good at telling you when you call things that don't exist. But when you run Pylint in the situation, it actually tells you that this import blend in module broccoli is unused. So it's not actually safe to remove the imports that Pylint says are unused. And it's not good enough just to search for the string broccoli.blend throughout your code base, because broccoli could be imported under an alias. It could be imported as banana, for example, and now banana.blend creates this dependency. So it's a little trickier. So that's when I realized it was time for a new tool. And after I thought about it, and the most natural name for the tool occurred to me, there was no turning back. So Star Destroyer is a tool you can run over your code base that will analyze your modules and actually understands these relationships between the imports and the modules. It knows that banana refers to the broccoli module, and it knows that banana.blend refers to the blend that was imported into the broccoli module from asparagus. It also understands that the names themselves can be aliased. So in this case, the call to glaze is actually a call to grill, which is imported into broccoli from asparagus. And if you let it, it will tell you what all of your things refer to, and it will, with your consent, go through your code and actually edit out all of those dirty, dirty import stars. In a case where you can't tell what an import might be referring to, so in this case, dynamically, this banana might refer to banana or broccoli, it will keep track of all the possibilities and only conservatively suggest to remove the imports that are safe to remove in all cases. So you can get this module from pip or run it like this. My name's Ping, and I'm at a little company called SendWave, We do mobile money transfer to Africa, so people can send money instantly to their friends and family in Africa. And if you're curious about Africa or mobile money or the way it's affecting and impacting some of the poorest people in the world, come talk to us. We've got the cute penguins on our shirts. Thanks a lot, and I hope Star Destroyer comes in handy for you someday.
Thank you. All right. With like 8 seconds to spare, that is awesome. All right, next up, we have Travis Morton talking about compromised data types for reasonable people.
Thank you. So my name again is Travis, and I'm a software engineer in San Francisco, and I'm the author of Compromise. So Compromise is the essence of engineering. It's really the most important thing. So I'm going to give you my actually favorite quote here about Compromise. I'll let you start off with that. This is a very live demo. So if you have a team, one starts to start, your index is at 0, the other one wants to start it at 1. We have this list object, and in sort of your elements of least surprise, exactly like you would expect, you can index off this way. And does everything you would think to, it slices, it starts, it stops. So this way people can meet in the middle, we're all happy, but for some, the middle is actually too rigid. So for them, I would suggest the flexible list, because flexibility obviously is super important here too. And you'll notice it's new. You know I'm doing a live demo now for sure. We now have this start attribute, and if we want to change that, maybe you have some team, I don't know, in some weird way, they like to do it like this. Then you can access it that way, again, exactly like you would expect. So some people can use it the way they want, other people can use it as well. The other big argument we have is between mutable and immutable types, those of us who like lists, those of us who like tuples in a more functional style. So we can then compromise in the middle here. So a semi-mutable sequence, we're actually going to 0 index here, so it's just like you would expect. Of course, you can't assign to a semi-mutable sequence unless you really want to. So the other thing that comes up very often is magic numbers. So let's say you have something that's 10 yards long, and in this case, we're wondering, so how much of that is in feet? And we'd have yards times 3. I know we have a lot of Canadians here, so I'll explain this for you. So obviously, this is totally unreadable. We should replace the 3, in this case, with a constant. And we now have our perfect feet, 30 this way. Now, that might be not quite enough, so maybe if we want to create some other constants as well, we could do 3 and point, which is like close enough. So we can do it that way too. Now, we all know how constants work in Python, which is they don't. So I really suggest you don't actually do that. Or do, I don't care. Go to town. You can do whatever you want. So this is Compromise. And I made it because it's really fun to just make something about this silly. I don't think you've mastered something until you can do it really, really badly. Would be a good idea. So if you want to contribute, there's test cases. There's more code. You can check out other shenanigans like this. Will be up on my GitHub. Stop by our House Canary booth. I'd love to talk to you about any of these sort of things. And like I said, with the coding challenges and stuff. Oh, it only runs on Python 3.5 because some things you shouldn't compromise on.
Thank you, Travis. That was awesome. All right, so another contentious talk, a flame war constantly at my company. We have Trey Hunter talking about how to mix tabs and spaces.
So my name is Trey. I do corporate Python training. I'm going to teach you how to mix tabs and spaces. As programmers, we use indentation to make our code readable. Unlike most programming languages, Python actually cares about our indentation, though. It uses indentation to figure out what our code blocks look like. So we can either use tabs or spaces in Python. But what if we didn't want to choose? What if we couldn't decide? What if we used a mix of both tabs and spaces? Now, you're probably wondering, what kind of indecisive fool would mix tabs and spaces? That's not what I'm going to talk about. I'm not going to tell you why to mix tabs and spaces. I'm only going to show you how. First, we need to talk about indentation. Indentation doesn't always matter as much as you might think. If you're continuing a block of code and you leave the parentheses open, or leave a brace or a bracket open, indentation doesn't matter at all. If you're making a new indentation line, you're indenting code, that doesn't really matter so much. And all that really matters is if you're aligning your code with the previously indented block just before it. Indentation does often matter, though. So if you're in the same code block, your indentation level must remain the same. You can't remove a space, you can't add a space. You can see the if statement on the right is a problem, and that try except on the other side is the problem there. So if a line of code is in the same block as the previous line, it must be indented the same amount. If a line of code is supposed to end the current block by being outside of it, it must line up with a previously indented line, or a previous indentation level, rather. If a line of code is forming a new code block, for example, the first line of an if or a while, it must be more indented than the last line. Okay, so those indentation rules are great, but what about mixing tabs and spaces? When using tabs, it's important to keep in mind that tab characters represent the number of characters until the next 8-character tab stop. So sometimes we can approximate this idea by saying that tabs are equal to 8 spaces. I'll show that here. So you can see that those 8 space characters highlighted in blue are seen as equivalent to that red tab. It's seen as 8 spaces there. These code blocks are both valid. You can mix your tabs and spaces, and it works just fine. However, when you put spaces and then a tab is not 8 spaces. A tab is the number of spaces to get to the next 8-character tab stop. So this is a little bit tricky. You need to make sure if you mix tabs and spaces, you understand what the tabs are doing and what the spaces are doing. You can get code like this. Lots of spaces that don't actually push to the next tab block until you have enough of them. So this is very important. If you are mixing tabs and spaces, you must configure your text editor to use tab stops that are 8 characters wide. Also, you can't use Python 3. Python 3 completely disallows indentation styles that mix tabs and spaces. But that's okay. That shouldn't be a problem because you never really have to upgrade to Python 3. You can just use Python 2 forever. Don't mix tabs and spaces.
Awesome. Thank you, Trey. Before we get into the next talk, if you want to give your own Lightning talk, there is sign-ups right next to registration. There's still room, I guess, for tomorrow night's and Wednesday morning's talks. However, we often get a lot of people wanting to talk, so I'm sorry if you're not selected, but please don't fret and enjoy your PyCon otherwise. You don't get mad at me, I'm sorry. All right, so going into the next talk, it's Tarian Kozak, sorry, and talking about Twitter bot fairy tales.
Hi, everyone. My name's Tarian Kozak. Like she said, I'm on Twitter as Spinecone, and I'm curious, I don't know if I can see hands from here, but do people know what Twitter bots are? That's some people. That's a lot of people. Okay, cool. Well, I am the co-organizer of Django Girls PDX. You can check out our booth in the exhibitor hall. And we just had our 3rd workshop on Saturday. And one of the things that we do at our workshops is we have an evening of little lightning talks. And I gave one on Friday going over what Twitter bots are. If you're not familiar with them, they're basically a robot that will tweet for you. It can tweet pictures and text and whatever crazy stuff you can come up with. And I talk about them at Django Girls because I think it's really cool for new programmers to have projects they can jump right into. Specifically, people come to Django Girls as attendees and coaches because they want to know how does a person learn to program, and some people who are better people than me can learn from books, but I personally learn by making things. And it can be hard to think of like what is worth my time to make. And so I think Twitter bots are great because you can take them in any weird direction you want. I'm going to talk about a couple that I've made. The first one is based on a thing that me and my little sister used to do, which is we would go to WikiHow and like a random article, and we'd take a word from this article, like lip, for example, and replace it with the word butt. So now you get how to make butt gloss, which is wonderful. When you make your own butt gloss, you can customize it to give it your favorite scent, flavor, and color. Butt gloss is easy to make on your own. And that's a picture of butt gloss. So I just decided one day to make a Twitter bot out of that. So now, 3 times a day, there's a butt joke that I didn't have to write. I didn't have to do it myself. A robot just does it for me. And it's a short little program, really accessible to anyone that's just getting started in programming. This is Ruby. My apologies. And here's some of my favorites. And that's how to butt. I accept pull requests if you have any cool ideas for butt jokes or anything else. And the second one is, this is a screenshot of an IRC chat. I had some friends over to my house recently, and I noticed they were all on their computers, like nerds do. And they started giggling, and like, what's going on here? And it was, they were playing with this IRC robot that if you said Taco Bell, it would generate a Taco Bell item, which if you're familiar with the Taco Bell menu, there's some weird things on there, but they were not real. So I had to investigate what this robot was doing. And this is the work of Britt, who was here somewhere waving his hands. He made this IRC chat robot that generates fake Taco Bell items, and I thought this was beautiful and amazing. So I wanted to contribute to this as a good open source developer. So I added Moss words. I added smothered, stuffed, and cantina. And then I also turned that into a Twitter bot called Taco Helper. It finds people that I think would benefit from tacos and then tells them a pretend Taco Bell item. And I think that this is a meaningful lesson for new programmers, that like you can go out and if like you're interested in tacos, that's really great. You don't need to go out and make the next JavaScript framework to like learn something about programming. Like you have the right to go and find something that you think is fun and make it, and you'll learn something. And this slide is not relevant today, but check out Django Girls. And if you're interested in making a Twitter bot for the first time, I made a tutorial at pineconedosthings.com/buildabot. You don't really need to have any background in Python. And that's it. Thank you.
Awesome. Thank you so much. All right, next up, we have Russell Keith McGee and his travel buddy, B2, talking about I Am a Doctor.
Thank you very much. For those who don't know me, I'm a 10-year veteran of the Django core team. I'm a member of the Django Technical Advisory Board, and until the end of last year, I was the president of the Django Software Foundation. I'm also the founder of the Beware project. It's a collection of libraries and tools for developing user-facing apps in Python. We've got a booth downstairs. Come by, or next door, come by if you want to know more. I'm also talking about this tomorrow. I'm also the CTO and co-founder of a startup company with all the pressures and stresses that come along with that. I'm also a doctor, but I'm an actual doctor. I'm a FUD. My doctorate is in computer science. My doctoral thesis was entitled Models of Learning and Development in Cohonan-Style Self-Organizing Feature Maps. And that's 3.5 years of my life I'm not getting back. The reason I say this, what I'm about to say is not medical advice. It's personal anecdote. But I hope that by sharing, I encourage other people to do something that I didn't do for a very long time. You may have noticed I have my fingers in a lot of pies. I've got a stressful job. I volunteer with Django. I've got side projects. My side projects have side projects. I have a son with learning disabilities. I have a daughter. I have a wife. And after the last few years, the combination of these stresses started to take their toll. My temper started to get really short. I found myself getting frustrated, both with myself and with others. I found myself doubting my own abilities. And I'm not just talking about, basic imposter syndrome level stuff here. I'm talking about a genuine belief that I was incompetent. My enthusiasm to go out and socialise with friends was completely eliminated. Picking up the phone to organise to go out with a friend, to go out to dinner, or to organise to have a friend come over for dinner felt like too much effort. And I had some intermittent health problems, especially with my shoulder and my back. It wasn't constant, it wasn't a continuous decline. I had good days, I had bad days. I had good weeks, I had bad weeks. But this pattern had been going on for probably somewhere between 18 months and 4 years. But about a year ago, I hit rock bottom. I woke up one Wednesday, I went to my home office, started work, and by 9:30, I had no energy to continue. I could not summon the energy to give a damn about anything. I went back to bed, buried my head in my pillow, and I cried. This was the final straw for my wife. She pushed me out the door to go see a doctor, a medical one this time, and I was diagnosed as being in the middle of a major depressive episode. I am now being treated. It's a combination of chemical treatment and psychological counselling, and even though it's been a year, I can't really claim victory, but I have noticed a positive change. At some level, it was probably just initially the cathartic relief of knowing that what I was feeling wasn't right and can be treated. But given what it feels like to bottom out, I'd take any improvement I can get. The reason I'm going public about all this is that in retrospect, I put off going and getting help for far too long. I didn't want to admit failure. I didn't want to attract the stigma of admitting that I was mentally ill. Successful people don't get depressed. Successful people power through. Successful people win. And that's bull. Studies universally agree that depression affects 1 in 10 people in the general population, and it's higher in some demographics. And guess what? This industry, computing and tech, is particularly prone, to the tune that discussions about burnout are almost a constant undertone. I want every one of you in this room today to know that you are not alone. I am, by almost every conceivable measure, a successful member of this community, and I have depression. I've given a version of this talk several times, and what's amazed me every single time is the number of people who have sought me out afterwards to thank me for being so open about it, because they had depression and they were afraid to seek treatment, or sought treatment but didn't want to tell anyone about it because of the shame. And it's shame that is quite literally, in some cases, killing us. There are people who should be here today, who could have been here today, but they aren't because they took their own lives. My plea to each and every one of you, don't ignore the signs. Don't put off getting help. If you've even got a vague feeling that you might be depressed or suffering from burnout, please seek help, because you don't have to feel like that. If you think you have a problem and you're at the point where you're wondering you have a problem, you almost certainly have a problem. Seek out help. Seek out medical professionals, or seek out organisations in our community who provide support for mental health. And if you're not depressed, if you're a well-adjusted, happy individual, well, first off, really? But secondly, I'm incredibly happy for you. Your job now is to make sure everyone else is okay. Depression is not about being, depression is not about being sad. It's not something you can snap out of. Depression is a lot more like a broken limb. If I was to break my leg, no one would tell me to shake it off. Everyone breaks their leg sometimes. No, you'd understand that it's painful, the bone is broken, and I'm going to have to use a crutch for a while to get around. Mental health is like that. Your brain is broken. The reason I gave this lightning talk, the reason I continue to give it, is that I suffer from depression, and I put off getting help for far too long. The reasons I did are really dumb and really easy to fix. This is my first US PyCon. It's been an amazing conference, and I'll be damned if anyone else in this room has to go through what I went through, if I can prevent it by being open about it. Thank you very much.
May I have a hug? Thank you. Thank you, Russell. That was really important to hear. All right, next up, we have Amit Shah speaking about doing math with Python.
Hello, everyone. Sorry. So yeah, my name is Amit, and I'm the author of the book called Doing Math with Python, and I have come from Sydney here to sell my book. So that's like the most important slide. So okay, but for those who are not going to buy the book, I have something else. So the whole idea is that the whole premise of the book and the whole premise of my talk at the Education Summit yesterday was that Python can lead to a more enriching learning and teaching experience in the classroom. And how we are going to do that, we are going to stand on some giant shoulders. And those giant shoulders are Python 3, SymPy, and Matplotlib. So how can you do that? We can do it in 3 different ways. So the first up is by showing how Python can be used as a scientific calculator. That very much looks like my calculator all the time because that's what I do to calculate my average grocery bills every month. Then we get to the math module and the descriptive statistics modules, which allows us to do more advanced functionalities. And using tricks like the Python startup environment variable, we can write our custom functions and make them easily available at the interpreter itself whenever we start it. So we don't have to import modules every time. Next is we can convert Python to a really fancy calculator by using SymPy. Do things like this, like we give the plot function an expression and comes out the graph. And we can solve equations or inequalities for that matter. We can find the limits of functions. We can find the derivatives of fairly complicated looking functions, or find the integral, or find definite integrals. And SymPy, for those of you who know about it, is obviously more advanced, has a lot more features than we care about at the beginner's level, really. But can we do more than that? We can. We can by making use of, well, again, Matplotlib, libraries like basemap to plot maps. The second image shows that. Then we have interactive Jupyter notebooks. I have a demo. I'm going to play that. That's like a projectile motion demo. So this is something I learned a couple of days back, which are funds they existed long before I did, and every one of us did, I guess. So for example, we can do, yeah. So this is the interactive notebook, and I can pull this slider, and I'll get this. I can play with it. I can make the students play with it and see how basically things change as they change the number of points. So I believe those small things lead to a very interactive environment for teaching and learning both. I'll skip that. And then all this is, I think, a great base for the future as well. So statistics and graphing data, I think those are our ideal base for getting into data science. Not to dumb down data science, but I think a lot of it is statistics. And one of the first steps is basically plotting your data just to see how the data is, like what are the correlation or what could be the relationship between the various variables. And then differential calculus lends itself very easily into machine learning because optimization is like the key step in those algorithms. And yeah, I think that's all. So thank you for giving me the opportunity. This is coincidentally my first PyCon talk on the big stage. So thank you.
Thank you very much. All right, next up, we have Cameron Durham speaking about savepyvideo.org.
Hello, I'm Cameron Durham. I've given some version of this lightning talk at a couple of places, PyTennessee and IndiePy, and I yelled about it other places. So you may have heard this before. So I'm Cameron Durham. If you want to get a hold of me in any way, you can find me at pinkhatbeard.com. Pinkhatbeard.com should be pretty easy. So I don't know if you guys are familiar with pyvideo.org. If you're not familiar, pyvideo.org is and will be was fairly soon, is a website where they have aggregated all of the videos of all of the talks that happen in all the Python events. And a lot of people use it to learn. It's where I send people when they're just getting started, hey, go check out these talks. They'll tell you why Python is this or why it's that. In January of this year, the gentleman who runs the, who was running it and built it himself, he decided he was going to stop maintaining the project and it was going to be discontinued sometime this year. So when I heard about this, I said, man, someone should really do something about that. That really sucks. So a couple of months later, I went to Pi Tennessee, and I did a lightning talk there, and I said, hey, there's this thing, it's happening, it's getting closed down. Should we save it? Do we want to save it? And the entire room of people at Pi Tennessee all said the same thing. Yes, it should be saved. Good luck. And I said, well, I would love some ideas. And they said, yeah, I'd love to help you, but you should do it. I don't have time, but you should do it. And so then I did another talk at IndiePi, where my local users group, and got kind of the same response. Got a couple of people more interested in helping with it. And so I started, I cleaned up all the data, I got all this stuff around, and then I got busy. Apparently, I have to pay bills still, and doing free work for the community doesn't do that. So I got really busy, I gave up. No one seemed to really care because everyone said, you should do it. And so what happened was I stopped working on it. I had intended on actually having it ready for PyCon and all of this, but I obviously didn't get to do that. And then it was Saturday night, I believe it was. I was sitting in the lobby of my hotel having a beer, and I overheard a table of people sitting right by me complaining about the fact that pyvideo.org was shut down, or was getting shut down. So I walked over to the table and I said, well, what are you guys going to do about it? And they said, that's great, you should do something about it. So that's what I'm doing. I'm here Thursday, Friday. I don't have a room yet, but I will be sprinting on pyvideo.org. I have a majority of the data cleaned. I do need help with a few things. If anyone knows anyone at archive.org, I need some help getting videos off of there, and I don't want to destroy their servers doing it. There's just a bunch of little things that need to be done on it, and a lot of ideas that we need to figure out how to make it so that this can never get shut down again. And that's the majority of it. So if you want to help out, you can get a hold of me. pinkhatbeard.com has all of my contact info. Thank you.
Awesome. Thank you. All right, next up, we have Renzo.
Yeah.
Awesome. Speaking about Python birds.
Okay, guys, so my name is Handson Italian, and I'm here to introduce to you Python Birds, this project that I have done. I was invited to give object orientation class at the university, and for my luck, we had there Fernando Massanori that has made a massive open course teaching Python in a fun way, and it was very successful. And inspired in that, I tried to make something fun too for teaching object orientation that I asked for the god of the demonstration that let me show you guys. So I have this first iteration here. I hope you guys can see the birds flying over the screen. Yeah? No? Can you answer? Are you there? Yeah. So I was very interested because I was the only one having fun with this game. All the students were seeing, what the hell? This is a game? I wasn't seeing these black marks on the screen. So I have told myself the biggest lie that you can tell, that once I have time, I'm going to do the animation. And 3 years later, I read the book Inventing Your Own Games with Python, and he has a great idea that doing animation with ASCII art, and I decided to do the second iteration at the time. I'm going to show you guys here. So I hope now you can see the birds flying over the screen, right? Right? Amazing, man. And I was really excited, you know, because I have made a video and put that on YouTube. I was really happy. And this friend of mine that have made this image for me, hey guy, come on, I have made this image for you, and you put that crap on the internet? Come on, guy. And I told him the second biggest lie that you guys use at work, that this is an agile process, so it's iterative. Once you have time, we are going to make it. Yep. So a former student and a friend of mine nowadays come up with the answer, because I would not use like Pygaming, because It's for beginners, and beginners would have problems installing third-party libraries. So he came up with TK-Inter that it's on the interpreter, and that was the fourth iteration of the project. I hope you guys can see it here. Oh, it's small, of course. Oh, so here we have the birds. You put the angle, and finally you have the birds flying over the screen. And you can, of course, have a replay, so people can see again what they have done and play again, something that the original game don't have. And that was it. I have still time here, so this is the, oh, thank you. So this is the open source project. I hope you guys take a Portuguese class to do this, because I write this in Portuguese, my original language. But last year, I have a 16-hour flight to Montreal, so I was plenty of time, so I have translated the project. I assume that at this point of my presentation, you guys have figured out that my English is not perfect, so if you guys wanted to help me to translate it, feel free to contribute. And that's it. Thank you guys for watching me.
Awesome. Thank you. That looks so much fun. All right, next up we have Rami talking about Python in the library.
Hello, everyone. I'm yet another member of the Reveal.js Users Club. And I'm going to be talking about Python in the library, AKA learning to be part of a community. So, little introduction. I'm Rami. I'm Necarus on the internet generally, so Twitter, GitHub, you'll find me there. And I'm from Washington, D.C., where we have taxation but no representation. I'm going to be talking about something that a lot of people have talked about, that our keynote speaker this morning talked about, which is learning and about literacy. And I'm going to talk about kind of some of the things that we're doing about that in DC. So we actually have a weekly meetup, which is a Python class, and we do that pretty much every week in DC. And it's not just learning the syntax. So how do we do it? We have a weekly drop-in class. Basically, everyone is welcome, which means we get all sorts of people that turn up. So at a recent class, we had someone who said, programming sounds fun. I've never done that before. How do I computer? And someone else who said, well, I get this multiple inheritance thing because I'm a C++ expert, but my meta class didn't work. And it's a great combination where you have that combination of skills and challenges. But how do you bring these people into the community? How do you make it just not about the syntax? Well, the first thing is a lot of what people have been talking about is computational thinking, and that's really key for us. So we make it interactive. We say bring your own computer, install Python, get a text editor. Pro tip, Anaconda makes this a snap on Windows especially, which is kind of my bugbear, but it's a great tool for other platforms as well. And we tend to do a lot of code-alongs. So, everyone ends up with working code that solves a problem that they understand kind of line by line. Everyone knows what this is doing. And then we put it all on GitHub, so everyone can go and look at the archives and everyone can learn from what they worked on. It's also really good to make it simple. So math is awesome. I love math. I've learned to love math, I should say. But relatable problems are better. So something that someone's like, oh, it's an anagram puzzle or a password generator or a word game, something that someone could say, I would actually want to do this, I see a purpose for this, is a great way to bring people in and start them thinking computationally. And we always need more ideas, so contact me on the internet with more ideas for ways that we can, interesting problems that we can use. And so now we're getting to the community part. So we needed a venue that's accessible to our audience. Our audience in this case was everyone in DC, because we want potentially everyone to be, there's a word, algorithm, capable of thinking in algorithms. So we use a public space. We use the library deliberately because it is accessible to everyone. You can walk in if you are, a member of this society. And the staff at our library have been awesome about this, and I'm sure the staff at your library will be too. So why do we want to do this? Well, a lot of what the Python community is fantastic about, and the keynote speaker this morning mentioned is, it's not just teaching syntax, it's spreading code literacy. It's making sure that people are able to work in our new world where software has already eaten it. And being there in person instead of having these online resources helps a lot more than you remember. I know I suffer from the problem where I learned to code and to think algorithmically so long ago that I've forgotten how much of an insane struggle it is to get started. And so I'm thinking, oh, this is relatively easy. And I'm like, you know what? It's not. And it helps so much to someone who's struggling with this new language, with these new concepts, to have someone there to just walk them through it. And the whole idea is you're empowering people to join the community by bringing people into this incredible, warm, welcoming fold. I'm not going to call them out, but I know a couple of people who started out coming to our weekly drop-ins are here at PyCon right now. So that's that power of community. So join us. Bring Python into your community space. If you're in DC, we need more people to help. So please do contact me, and I'm going to be doing an open space tomorrow, so keep an eye on the board. We would love your input. Please come and join us bringing Python to the wider community. Thank you.
Awesome. Thank you so much. All right. I'm going to butcher your name because I didn't mess it up or didn't talk to you before. Aaron Broswell. Awesome. Render all the things in the browser.
Yes. Hello. My name is Aaron, and I'm going to talk about rendering stuff, files specifically, in the browser using Python. So I am a developer at a place called the Center for Open Science. We are a tech nonprofit in Charlottesville, Virginia, and we make stuff for scientists to use to make science better. That's our #1 thing. And we also happen to make a lot of open source stuff for developers to use to make their own stuff better. And I'm going to talk about one of those tools that we developed, and it's called the Modular File Renderer. And I'm really glad I said the word modular right, because it's really hard for me to say. But it's one of those convenient names because it tells you exactly what it does. It is modular, so you can use it anywhere you want. It takes files, and then it renders them in a different way, in this particular case, in HTML. So one of the ways we use the modular file renderer is to display files that scientists upload to one of our tools called the Open Science Framework. And I'll show you a little bit how that works. So here's the MFR in action on the Open Science Framework. So this is, in particular, it's taking a IPython notebook or a Jupyter notebook file and rendering that in the browser for you. And this is nice because you can send a direct link to someone, and they can see all of the output from your IPython notebook file. Or if you happen to be a scientist like the fish guy, Adam Summers, who is awesome, by the way, he has uploaded over 25,000 3D fish scans to the Open Science Framework. And he uploads them in a file called STL. And you can actually, of course, it's not there, even though it was there a second ago. But I'm going to pretend like there was a really cool 3D rendered model of a fish skeleton rendered right there in your browser for you. And that's one of the things that the Open Science Framework does. And this is a clingfish. And if you're interested in seeing more, you can follow him on Twitter with the hashtag #ScanAllTheFish, because that's what he wants to do, is scan all the fish, and he's putting them online. And then people can see them using the modular file renderer. So what it does is it essentially takes a file, checks out the extension, and then converts that file into HTML in a format that that extension needs. And then the modular file renderer gets then passed a URL, and then you can render it as you want, so like in an iframe or something on your website. And it is, of course, open source. You can find it at Center for Open Science /modular file renderer, and it's also pip installable, so if you want to just use it to then render files. And these are the file formats that it does so far. And of course, at the end, there's your favorite file extension because it's an open source project. And so if you would like to see it do something new, you can yourself contribute to it. I personally want to add a FITS image renderer, which is an astronomy file format that is dear to my heart. So that would be really great. And yeah, so that's all I have. You can find these slides also online, and big plot reveal. This entire presentation was being rendered on the modular file renderer. Whoa. Anyway, thank you.
Awesome. Thank you so much, Aaron. All right, next up, we have Doug Matzke talking about information is physical.
Hi, everybody. My name's Doug Matzke, and my friends call me Quantum Doug because I like all things quantum. I guess I'm a nerd because I like math and programming and physics and fundamental things. And so I figured other nerds like that probably are here and probably would want to talk about these things. So I wanted to introduce this idea. And probably people in computer science should know that physics has an understanding of information a little bit different than we do. They now know that information is actually physical. And so that's what I'm going to be presenting today, and hopefully I'll convince you that this is an important subject for us to talk about. So what is my background? What do I have? Who am I that I have something to say about this? Hopefully you can see that. Yeah, I mean, I've been programming on the Lisp machine at Texas Instruments for 10 years in the 80s and 90s, and then I went and learned Python, and been doing that for 15 years. And I currently work at Z Omega in Dallas for the last 2 years. And I was interested in this stuff for a very long time. In 1992 and 1994, there was some Dallas conferences and workshops that I produced on physics and computing. And like the only other two conferences like this was in '81 that Richard Feynman was a keynote speaker on, and another one in '96 by Tom Toffley. He was the organizer for those two. And so I'm interested in sort of like limits of computing and limits of computers. And so I wrote this article. It was a lead-off article on 1997 on the Computer Magazine on the billion transistor processors issue, and will physical scalability sabotage performance gain. It basically says wires don't scale, and it predicted 5 years ahead of the time that said, hey, wires aren't going to scale, so by the time we have a billion transistors, it won't be a uniprocessor, it'll be a multiprocessor. And that was exactly what happened in about 2003. So in about 2002, I actually got a PhD in quantum computing late in life, and I was tired of matrix math, and it didn't look very reasonable to me, so I wanted something that looked more algebraic. So I discovered this thing called geometric algebra, and I did my PhD in quantum computing using geometric algebra and showed that a qubit could be defined completely using real number algebra rather than complex number algebra. And it also predicted that there's entanglement differences compared to the regular Hilbert spaces. So I don't know what that means yet here 15 years later, but those were the kinds of predictions. Also, I got a SBIR contract for $1 million to work on quantum and neural computing and several patents and new research on that. So as you can see, I've been doing this for a long time, and I built a bunch of software in Python, both for quantum computing using geometric algebra and regular Hilbert space notation, and also this thing called sparse distributed coding, which is all related to that. So one of the things we want to tell you about is bits are really part of physics. And why do we say that? Well, information is physical. The first guy who presented this was actually an IBM fellow named Ralph Landauer. He was the keynote speaker for that '92 conference. And he predicted this back in 1961. And he said the minimum energy due to bit erasure cannot be ignored. Otherwise, you violate thermodynamics and the second law of thermodynamics. So what's interesting is this was actually measured in the laboratory about a year and a half ago, December 2014. So now we know from 1961 all the way to 2014, it took that long for them to decide that this was real and they needed to measure this. So, also, famous physicist John Wheeler stated in 1989, he said, "It from bit, everything comes from bits." And a bit, in fact, is the smallest change that you can make to a black hole. And why is that? Because everything is physical, he says, and it's required for self-consistency of quantum gravity in black holes. You have to have information theory, quantum theory, black holes, quantum gravity, and information theory, entropy, all consistent in black holes. And that's the net result of that, is the smallest change you can make to a black hole is a bit, which ends up being about Planck's area on the size of a bit. That's the discrete smallest amount you can add to a black hole. So here it is. The information is physical. Also, the other important thing is Shor's algorithm came out in 1994. He was a keynote speaker for my other convention in 1994, and he showed that you can create, using a quantum computer, you can solve a problem that no classical computer can solve. You go, how is that possible? Well, it surprised everybody because it even created a new complexity class called quantum polynomial time. It says that using a quantum computer, you can solve a problem that no classical computer in linear time using a quantum computer. And so it does this by cheating because it uses dimensions that aren't physical. It uses these mathematical dimensions of the quantum space to do computing. And so to me, as a computer scientist, I should be interested in that. And a lot of the more physics-oriented computational scientists are people who are interested in it, like Peter Shor. It turns out there's a thing called quantum Fourier transform that actually does the work for that algorithm. So here is the hyperdimensional reality is the last piece. quantum computing has the classical bits, the qubits, and of course the e-bits which are entangled, okay? And there's four private dimensions in each non-local dimension. And so once you realize that the universe has hyperdimensional spaces, every e-bit has 4 dimensions, you realize there's a lot of dimensions out there, and there's a whole math associated with that called sparse distributed coding, okay? And so if you're interested in this, I'm going to try to put together a open space project tomorrow, and if somebody's interested in, in coming and talking to me about that, let's do that. Okay, thank you.
Thank you very much. All right, our final talk for tonight, J. Miles Holmes, talking about road trip to PyCon.
Hello, PyCon friends. So I drove a long distance across the country for the 3rd time to come to PyCon. This is, again, the 3rd time I've done it. This time I did it with myself, my partner Chelsea, and our little baby Fibonacci. Last year I did it with Kieran Prash, who also drove on his own road trip across the country this year, and we managed to stay at Python houses across the country. It's amazing. You just put the word out on mailing lists and on Twitter, and pretty soon you've got like a couch or a bed to sleep in all across the country just from this, this community, this ostensibly just a programming language, but really almost more like a movement called Python. Last year, you may remember, right, standing at the closing remarks, Brandon Rhodes implored the people of the audience to get in their covered wagon, pulled by a team of oxen, travel from Independence, Missouri to the fertile Willamette Valley of the Oregon Territory. And so we took him up on that. This is Fibonacci getting ready to go here. Only our covered wagon was a 1995 International 3800, and it did a pretty nice job for us. We set out from Independence, Missouri, as one does, and we hit the usual landmarks: Fort Kearney, Chimney Rock. You've played the game, you know these. Come on, we lost a wagon tongue at one point. It was actually a headlight, but I like to tell people it was a wagon tongue. Actually, interestingly, we had a little bit of a leak in the one of the emergency exits of the bus, which I later replaced with like a skylight, and I had to actually get out the silicone and fix it, and I realized that I missed a perfectly good opportunity to take a picture and tell everyone I caulked the wagon, right, to cross the Kansas River. Next year. We did Fort Laramie, of course. We noticed that there are these ruts across the country. Now, what's interesting about this is that some types of terrain seem to preserve the ruts better than others from the wagon trains over 100 years ago. And, it really kind of gave us pause. Many of you may know me as Justin, which I go by east of the Mississippi, but I started going by my middle name, Miles, west of the Mississippi a few years ago. And I started to realize that Miles kind of maybe almost embodies some different characteristics personally, and it kind of started to make me realize the importance of travel, the importance of looking away from a screen and instead through a windshield where the matter before my eyes is changing all the time. We met so many friendly people across the country during all of these 3 road trips that we've done so far, and I'd really love perhaps to tell you all about them in a full talk in a future year. You get the enormous sense driving across the country that the open source community is a particularly good reason to drive across the USA, that attending an open source conference is a particularly good reason. Because open source is about freedom, right? Prosperity and simplicity, and about making things ourselves. And at this time of such acrimonious civic discourse, there is a real thirst for that across the country. And, going across the Oregon Trail, I wanted to be sort of sensitive about what that means, westward expansion vis-a-vis the native population and these kinds of things. But ultimately, at the end of the day, I think it's just important for us to remember our hugely growing movement, our ideas of open source technology, that what people really want is just peace and prosperity. So I just wanted to urge you all to go forward, treating people with good purpose, with peace, and in Python. Thank you. And we're doing it again next year, so please join us again next year. And at the sprints, we need a little bit of help building like a captive portal that we'll share on the highway, sort of almost like a how's my driving bumper sticker, but with an SSID that you can join and have little micro communities going down the highway. So please, join us and help us with that, and please do join us next year for our next year's road trip. Thank you so much.
Thank you. All right, thanks, folks. Tomorrow morning, 8:30, we have some more lightning talks right before the keynotes, and then tomorrow evening, same time, same place. All right, see ya.